Hello everyone, this is Mr. 13 Things, or Silent Said Good, depending on which channel I am recording to, and I am continuing on a little bit almost finished product to talk about how we lay things out in patterns of 13 for memorization perhaps, or for learning, for checking, and of course we're looking at once again the start of that concept, which is kind of, if you think about it, a 24-hour clock. Where each hour is 15 degrees. If you want to think about where the whole concept dividing up the circle into 15 degrees, that is how far the world rotates in about an hour. It's a little off, just so you know, because of the complexities of the way the sun goes around its own axis, and the Earth goes around its own axis and the sun. Be that as it may, you're going to see as we lay out into the quizzing mechanism, we're going to be putting things up on the hours on the clock, which, and if you think about it, would be like, this would be at 12, and this is 1 o'clock, and this is 2 o'clock, and this is 3 o'clock. I'm going to edit undo that. So that's the way we'll be quizzing on them, because we're going to quiz them through with 13 points on 12 points on a circle plus 1 in the middle. But in terms of learning them and laying them out, we're going to see very often we're going to densify up to 24 or 25 things at once as we start to expand. So the basics, or the layout, or where this set of ideas came from was the concurrence of teaching my kids, and also working with others and learning myself, digging into some of the beauty of mathematics. And in the end, when I dug and looked and found, it turned out that there was a set of things, numbers, concepts that took primacy, if you would, in mathematics. And when I say mathematics, it's more of the beautiful math. And those turned out to be E, Euler's number, I, the imaginary number, or the square root of -1, EI, and pi, and you'll see that those come together in a second. -1, 0, 1. Pythagorean's number, square root of 2. Theodorus' number, square root of 3. Just the square root of 5, which you'll see later where that comes from. The golden ratio, or phi. The concept of infinity. A matrix, and a vector. And now I know there's supposed to be 13 things. I'm going to talk my way through and see what I missed. EI, pi, -1, 0, 1, the square root of 2, square root of 3, square root of 5. Phi, infinity, a matrix, and a vector. And we see there is 12 things there. Now, if you look across the top of the web page, I know I'm missing something here, and later on it may become clear as I start thinking about these concepts. EI, pi, -1, 0, 1, the square root of 2, the square root of 3, the square root of 5, the average of 1 and the square root of 5, which is phi, infinity, which is 1 over 0, a matrix, and a vector. I'm going to pause right here because I'm really proving something here that I don't know the 13 things, but I do know that I'm missing because I haven't counted my 13 things here. Well, that's embarrassing. If we count truly, you'll see that there are 13 things here because I put 6 in the first stack here, which kind of goes to prove why, in effect, we may be learning to lay things out in this pattern and fill them in. So let's put these things now where we might want them, and we're going to just go. We'll tell you there's no particular order to these, but there is a little bit of an order in that the way we learn them may help us to put things together in sort of visual pattern, as might be seen in the book or video Sacred Geometry, which talks about the geometry of jazz chords and music. So here we go. We're going to put E there, I there, pi there, -1, 0, 1, which puts us to Pythagoras' number right here, which is a pretty good place to put it. Square root of 2, Theodorus' number, square root of 3, and of course square root of 5, which you'll see later why that's important. It comes up a lot, but this is the golden ratio, not the empty set symbol, as some would see. The golden ratio phi, infinity, a matrix, and there's all kinds of ways to write a matrix, but I'll try to do that for now. And then a vector, again, all ties the ways to write a vector, but I'm going to put there. So we now have learned 13 things. And for y'all, this may not be the 13 things that you all think are important, but why not learn 13 things and their importance to some people like Sarah Flannery, who writes books about cryptography, or most anyone that deals in some sort of science, mathematics, or mysticism even, will somehow get involved in all of these things. So let's talk about quickly, just a little bit here, what they all are. Well, E, and I'm going to kind of realize that down below here I do not have the use of that screen. E might be in fact 1 plus a very small number, to a very large power. I might be something like the square root of minus 1. Pi, you're going to see it's going to have all kinds of different approximations, so we're just going to say circumference divided by diameter. Minus 1 is the opposite of 1. 0 is, or this is basically, I'm going to say this flips something. You multiply something by minus 1, you turn its direction. 0, if you multiply it, it negates or nullifies or gets rid of. 1 just keeps it the same. The square root of 2 is a really irrational number. It's kind of the most important irrational number. Another irrational number, another irrational number. And if you think about this as you go through, you don't see the square root of 4 here, because that's 2. 2 also is an important number. You'll see that the golden ratio is in effect the average of the square root of 5 and 1. It's a lot of other things as well. Infinity, all kinds of other things, but basically we're going to think about that as the tangent of 90 degrees. You'll see why later. A matrix and a vector. Of course, the most important matrix that we're going to think about to start with is, I'll just do this, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. This is a combination transformation and rotation matrix, but it is the identity matrix. So this does absolutely nothing. When you apply this matrix to a vector, and we'll put the vector here as x, y, and z and a 1 floater, you apply this matrix to this vector, you end up with the same vector, because you are basically multiplying a vector by the number 1. In context here, you will see there is a set of tools that you can apply in some way, shape, or form beginning as far back as 4th grade, where if you start using calculators, you can plug bigger and bigger numbers into this to get closer and closer to E. You can maybe flip things, but more importantly, the one thing where this comes from in terms of this order is the fact that E to the I pi equals minus 1. And there's a little dance that goes along with that, but you can see that in the end there becomes a relatively reasonable way to tie all these numbers together in their first pass, so not only do you learn them individually, you learn them in groups. So there it is, 13 things, the 13 things that Mr. 13 Things got started on, along with the concept of the unit circle and the wheels on the bus, and once again trying out the medium of recording on a 1280 by 720, basically a HD medium, but hoping it fits down onto other devices as you scale things down in YouTube. Thanks for listening.